right here. So if we go on, the most important thing to know when factoring is obviously what is a factor. So according to our friends at Merriam-Webster Dictionary, it is one of two or more numbers, algebraic expressions, or the like, that when multiplied together produce a given product, aka a divisor. So in layman's terms, because nobody understands that, is say we have the number, I don't know, 12. Okay? All of the factors of 12, and this is a factor tree, we can break it down into 6 and 2. Then we can break 6 down into 3 and 2. Okay? This is called a prime factorization, where sometimes you need to break it down to all the prime factors, but other times you just need to find out what are the factors of 12. So the actual factors of 12 are 12 and 1, 6 and 2, 4, and 3. So, and actually all of them are here, because if you look at it, here's 6 and 2, and then 3 and 2 times 2 is 4, so 3 and 4 is represented with this little curve right here. 6 and 2 is there, and obviously 12 and 1. Okay, so one of the things you have to be able to do, though, is break an expression down that has variables and a number. Okay, so we want to break this down into the smallest we can break it. So let's break the 36 down into 9 and 4. Then the 9 goes to 3 and 3. And the 4 goes into 2 and 2. So basically the smallest we can break this down is to 3, 3, 2, 2 times x, x, x times y times y. Okay? This is what we call prime factorization. We break the expression down into all of its prime factors, because 3 and 2 cannot be broken down into smaller numbers since they are prime. Which prime means, if you forget, it's only divisible by 1 in itself. Okay? This comes very handy when we're factoring various things. So one of the biggest ideas in factoring is finding a GCF. GCF, which correlates to the greatest common factor. Okay? And basically, you need to find the GCF a lot of times when it comes to factoring. So we'll just start off with an easy one. If we have 8x squared and 4x to the third, you first want to break it down into what can these both become. So we'll break this down to our prime factors, and it's a 2 times 2 times 2 times x times x. And this breaks down into 2 times 2 times x times x times x. Okay. Now what we can do is we can circle everything that they share. So they share 1, 2, 2 2's. Since they both have at most 2 2's, which gives us 4, because 2 times 2 is 4. Then they share 1x, they share 2 x's. Okay? So when you multiply x and x, you get x to the second. So the GCF of 8x to the second, 4x to the third, is 4x squared. Okay? So that's probably one of the biggest ideas, because whenever you factor, you always want to see if you can pull out a GCF. It'll make your life a lot easier if you can, but you can't always. So back to another example. Let's say we have 15x squared and then 20x y. Okay? Break 15 down in to 3 times 5. X squared is just x times x. 20 becomes 2 times 2 times 5 times x times y. Okay? Now again, let's circle what they have in common. They share 5 and they share 1x. Okay? So the GCF between them is 5x. Okay? Now, one of the shortcuts that I like to tell my students is that when you're talking about variables, if both terms have the same variable, whereas both of these have an x, whichever x is the lowest exponent, that's what your GCF is. So for instance, this is x to the second and x to the first. Since x to the first is a lower exponent, that's what's in our GCF. And even back here, we have x to the second, x to the third. X to the second is in our GCF since the 2 is obviously less than 3. Okay. And then knowing the GCF from just looking at them with the numbers just takes practice. It's something you won't really pick up on right from the get-go, but you'll figure it out as you go along. Okay. Now to move on to a little more complicated problem. I'll bring back this example, except I'm going to write it 4x to the third plus 8x squared. Okay. If you go back to this problem, we already said that the GCF is 4x squared. And this is the first real problem where we're factoring something out. Okay. So you're going to write the GCF, which is 4x squared. And factoring is the opposite of a distributive property, which is what we did a lot of last chapter. So when we factor out a 4x squared, think of it as division. Okay. So if we have 4x to the third, we're factoring out a 4x squared. The 4's cancel because 4 divided by 4 is 1. And x to the third divided by x to the second is just x to the first. But we don't have to write the 1 because we're professional mathletes, so we don't do that. But because if you remember, same bases divided by each other, you subtract the exponents. 3 minus 2 is 1. So when we factor a 4x squared from 4x to the third, we're left with just x. Then when you factor a 4x squared from 8x squared, well, we can do the same thing. Okay. 8 divided by 4 is 2. X squared divided by x squared is just 1. So when you factor out a 4x squared, you're left with an x plus 2. And this would be your factored answer. Okay. And the reason why I said it's the basically the opposite of distributing, because say we want to go back and distribute this 4x squared back into our parentheses. Okay. 4x squared times x would give us 4x to the third. And then 4x squared times a positive 2 is just 8x squared, which brings us back to what our original problem was. So this way is distributing, whereas going from the bottom to the top is factoring. So if you want, you can kind of think of them as inverses or things that undo the other, like multiplication and division, addition, subtraction. Distributing and factoring are kind of the opposites. So we're going to be doing a lot of that, so make sure you pay attention and understand that idea. So the next one we can look at, let's do 16xy, we'll do x to the second, plus 24xy to the third. Okay. A common number between 16 and 24. We want to think of the largest one, the greatest common factor, which is going to give us 8. Like I said before, we have x to the second and x to the first. So since they both have an x, and x to the first is the lower exponent, our GCF is just an x. We have y to the first, y to the third, so it's just a y. Okay. And again, when you factor, think of division. So 16 divided by 8 is 2. X squared divided by x is x. Y divided by y is just 1. So we're good with our first term. Then 24 divided by 8 is 3. X divided by x is 1. Y to the third divided by y is y squared. Okay. And this is the answer. And if you notice, all we're doing right now is factoring out the GCF. We're pulling out the GCF. That's what you always want to do first before you do any factoring problems, because a lot of times it makes your life a lot easier if you can pull out a GCF. So we'll do one more. Maybe I'll do a tricky one. Okay. This one is one of my favorites. I don't know, let's see. 8x to the third plus 16x to the fifth. Okay. Now this is 3 terms. Basically, the only thing that changes from 3 terms to 2 terms is you just have to make sure that every single term has what we're pulling out, since there has to be a factor of everything. So 4, 8, 16. Highest number is 4. Does every term have an x? Yes. What's the lowest exponent? 2. So x squared is our GCF. Okay. Now, this is where kids get really confused, or they kind of forget this a lot. What I'm going to do is I'm going to take this 4x squared and move it to the back. I didn't do anything, I didn't change it mathematically, I just changed the way it looked. So we factor out a 4x squared from 8x to the third. 8 divided by 4 is 2. X to the third divided by x squared is x. 16 divided by 4 is 4. X to the fifth divided by x squared is x to the third. 4 divided by 4 is 1. X squared divided by x squared is 1. A lot of kids would just put the parenthesis and call it even because they said this disappears. But in reality, we have to have a placeholder there. So 4 divided by 4 is 1. X squared divided by x squared divided by x squared is 1. And that's your answer. You must put the 1 out here in the back because it's placeholding for this term right here. So if we were to distribute back through, our answer would still have 3 terms because you can't leave anybody out. Okay? So, but your answer for factoring would just be this. Okay? And that's factoring out of GCF. What we're going to do next is factor trinomials, but I'll say that for another video. So, thanks for watching.